Okay, so let's go to question number 7. So question number 7 is asking us, find the highest common factor of the numbers below. So we got 12 and 24. So let's find out what the word highest common factor is. So let's go to the internet and let's see what it comes back with. And it says the highest number that can be divided exactly into each of two or more numbers. So let me explain. So I'm going to write down the factors of 12. So the factors of 12 is the numbers that can go into 12, and which are 1, 2, 3, 4, 6, and 12. And then I'm also going to do the same thing for 24. So I'm going to list down all the numbers that goes into 24. So 1, 2, 3, 4, 6, 8, 12, and 24. Okay, both are done. So then I'm going to do is I'm going to find the highest number that can be divided exactly into those two numbers. So from the list, I can see that 12 is the highest number that goes into both 12 and 24. So the HCF, or the highest common factor, is 12. So this is method number 1. And let me show you method number 2. So method number 2 is similar to the question number 6 LCM question, which is the inverse cake system. So we're going to have 12 and 24 written side by side. So if you can't think of 12 straight away as the number that goes into both 12 and 24, you could just break it down slowly. So what I mean by that is you can just say, okay, so what number goes into both 12 and 24, which is 6. Then you're going to do 12 divided by 6, which is 2. And then 24 divided by 6, which is 4. Then you're going to look at 4 and 2. Can you find a number that goes into both 2 and 4? Yep, 2. Then you're going to do 2 divided by 2, which is 1. And then 4 divided by 2, which is 2. Can you find a number that goes into both 2 and 1? Nope. And that's where you're going to stop. So when we were doing the previous question, what we did is we circled those through values. So the values on the side and also the values at the bottom to find the lowest common multiple. But to find the highest common factor, what we're going to do is just circle the numbers on that side and multiply them. So in this case, we're just going to multiply 6 and 2, which gives us 12. So the highest common factor is 12. All right. And also, surprisingly, there's also a method number 3. So method number 3 will require us to draw a factor tree of both 12 and 24. So I'm going to write down 12 on this side and 24 on this side. So with 12, I'm going to write down, so I'm going to draw these two sticks. So these two sticks is going to symbolize two numbers that multiply together to give me 24. And those two numbers can be 3 or 4, or you can do 6 and 2. It doesn't really matter. So then what you're going to do is you're going to have a look at each of those numbers in turn. So let's have a look at number 3. So is 3 a prime number? Yes. So I'm going to circle it, and there's nothing further I can do to number 3. Then I'm going to have a look at number 4. Is 4 a prime number? Nope. So I'm going to draw those two sticks again. And then I'm going to think, okay, So what two numbers multiplied together gives me 4, 2, and 2. So have a look at 2. Is 2 a prime number? Yes. So circle 2 and 2. And then just below it, I'm going to do 2 times 2 times 3. Okay. So essentially what I've done is I've just wrote down the prime product of 12. So I'm going to do the same thing for 24. Draw those two sticks and think, what two numbers gives me 24? Okay, so the reason why I'm drawing those two sticks for 24 and 12 is because 12 and 24 are not prime numbers. So just to clarify. Okay, so two numbers that gives me 24. So I can think of 8 and 3, but obviously you can do 6 and 4, 12 and 2, or 4 and 6. So it's completely up to you. Then you have a look at 8 and 3 in turn. So let's have a look at 3. Is 3 a prime number? Yes, circle it. Is 8 a prime number? Nope. So draw those two sticks out of it. And then write down two numbers that multiply together to give me 8. So I got 4 and 2. Look at 4 and 2 in turn. So let's have a look at 2. Is 2 a prime number? Yes. Circle the 2. Is 4 a prime number? Nope. Can it be broken down? Yes. 2 and 2. Is 2 and 2 a prime number? Yes. So circle those two numbers. And just as we did for 24, we're going to multiply those numbers out. So 2 times 2 times 2 times 3. Now, what we're going to do is have a look at that 2 on that side and have a look at the numbers on this side. So what I'm going to do is I want to cross out the numbers that appear on both sides. So 2 appears on both sides, so I'm going to write that down once. So this 2 appears on this side and this side, so I'm going to write it down once. 3 appears on both sides, so I'm going to cross it out, times 3. And what I'm going to do is just multiply those numbers out. So 2 times 2 is 4, times 3 is 12. So that's method number 3. Okay, question number 8 and the final worked example for topic number 4 is find the LCM, so lowest common multiple, and HCF, which is the highest common factor, of the numbers below, 18, 30, and 21. So I've already talked you through various different methods you could employ, but for me, I'll prefer to use the inverse cake method for this question. So 18, 30, and 21. So let's work out the lowest common multiple first. So then you're going to do is we're going to have a look at 18, 30, and 21 and think which number goes into those three numbers. The number that I can think of is 3. Then you're going to do 18 divided by 3, which is 6. 30 divided by 3, which is 10. 21 divided by 3, which is 7. So can you think of a number that goes into 6, 10, and 7? Nope. So to find the lowest common multiple, you have to multiply all the numbers that appears on the side and also along the bottom. Okay, so we have 3 times 6 times 10 times 7. So 6 times 3 is 18 times 10, which is so 18 times 10 times 7. So we got 180 times 7. So we'll do 180 times 7 on the side. So what's 0 times 7? It's 0. 7 times 8 is 56. So put the 6 down and carry the 5. 7 times 1 is 7. Plus 5 is 12. So the lowest common multiple is 1260, and to find the highest common factor is you just look at the number which appears on the side of this inverse cake method, and we got a 3.